Assalamu alaikum students. Today we are going to learn transverse wave and longitudinal wave. We are going to identify them, as well as we are going to discuss wave motion produced by vibration in rope, slinky spring, and water waves. Okay. First we are going to discuss what are transverse waves, but before that we are going to discuss waves. Waves are oscillation accompanied with transfer of energy through medium or space. So transverse wave is a kind of wave motion in which particles of the medium oscillates perpendicular to the direction of propagation of the wave. Means the particles move rightward, so the direction of propagation moves upward or downward, or vice versa is also true. So the examples of transverse wave is vibrating rope, slinky spring, water waves, etc. So first we are discussing vibrating rope, how it is acting as transverse wave, and how does the particle of the medium oscillate perpendicular to the direction of propagation of wave. Propagation means movement. So you can see in the diagram we do have the rope, which is periodical disturbance created by the string. So continuously it is being moving up and down, up and down. The particles are also oscillating up and down, while the wave is moving rightward, so making an angle between them 90 degree. Now again take another example, just like the slinky spring, in which disturbance is created by this slinky spring or the light spring by moving it up and down, while the disturbance that we can see, the particles of the medium of the ring of the spring, that is moving towards right, making an angle 90 degree. So again it is having a transverse wave, because the angle between particles of the medium and direction of propagation of the wave that are perpendicular to each other. Now we do have another example, that is water waves. Continuously you can see that as the water wave is propagating, so this red color like ball that will move up and down while the wave is propagating, or while the wave is moving towards right, making an angle 90 degrees. So again water wave is also a transverse wave. Now come to the longitudinal wave, the type of wave motion in which particles of the medium move parallel to the direction of propagation of the wave, or move parallel to the direction of motion of the wave. So here the angle between them will be 0 degree. The examples of longitudinal waves: a push or pull of spring. The second one is sound wave. Now let me have the first case, that is push or pull of slinky spring. Now push or pull of slinky spring, you can see that continuously as we create the disturbance in the spring, the regions will be created right here as compression or rarefaction. Now question arises, what is compression and what is rarefaction? Compression is the region of longitudinal wave, or the mass or the spring, slinky spring, in which the rings are getting closer to each other, and rarefaction is the region where the rings are moving away from each other. So as the disturbance we do create, that will move away from the source of the disturbance and transfer energy from one point to another point. So continuously we can see that this disturbance is propagating towards right and left, while the wave is also moving right or left along with the particles of the medium which are parallel to each other. So hence we do have the slinky spring. In the case of push or pull, we do have longitudinal wave. Thank you.